Hello friends, I hope all you are doing good. Today we are going to talk about Kubernetes with Terraform. We'll start with the introduction, what is Kubernetes, what is Terraform, and then we'll follow up with a hands-on lab on Kubernetes with Terraform. Today's agenda is what is Kubernetes, which is also called K8 in short. Then we're going to discuss what is Terraform, which is a infrastructure as code tool. Then we'll talk about Elastic Kubernetes Service, which is a managed Kubernetes service provided by AWS. And then we'll do a hands-on lab on Terraform with Kubernetes. So first, let's see what is Kubernetes. Kubernetes is also called K8, is an open source container orchestration system for automating software deployment, scaling, and management. So this is a system where you can automate your containerized application. You can handle management. There are many benefits to using Kubernetes. You can automate the operations such as Kubernetes has built-in commands to handle a lot of heavy lifting that goes into application management. So allowing you to automate day-to-day operation. You can also make sure applications are running the way you intended them to run. You can also handle the infrastructure abstraction. Like when you install Kubernetes, it handles the compute, networking, and storage on behalf of your workloads. This allows developers to focus on application and not worrying about underlying environment and the infrastructure. So those are the things you don't need to worry about. Kubernetes will take care of that. It also provides service health monitoring, so you can set up your own observability and monitoring system on the Kubernetes for your containerized application. So Kubernetes continuously runs health checks against your services, restarting your containers if that fails. So these are the major benefit of Kubernetes, and there are many use cases you can use Kubernetes. Like when you want to increase the development velocity, so Kubernetes helps you to build cloud native microservices based applications. It also supports containerization of existing applications, thereby becoming the foundation of application and modernizing and letting you develop application faster. And also it deploys application anywhere, so you can deploy application anywhere, as you know. If you have the Docker image, you can deploy the Docker image anywhere. It can work in your public cloud environment, it can work in on-prem environment, it can work in your hybrid deployment also. So what is EKS? So EKS, Elastic Kubernetes Service, there are different providers, cloud providers like GCP, AWS, Azure Cloud, so and the OCI, Oracle Cloud. So they all provide their Kubernetes, managed Kubernetes service. So EKS basically the managed Kubernetes service provided by the AWS. GCP has their own, which is called GKS, Google Cloud Service. Azure has their own, which is called AKS, Azure Cloud Service. The concept behind all these managed Kubernetes services are the same. So if you have the managed Kubernetes service, say for example, if you have EKS, then you don't need to worry about maintaining your or installing or operating your own Kubernetes control plane, nodes, and having them upgrade all the time, because AWS will take care of that maintenance part. Next, let's see the Kubernetes components. As you see, Kubernetes have many components. So the Kubernetes cluster consists of a set of worker machine, which we call nodes. So nodes are basically nothing but a virtual machine. In EKS, it's called EC2 instance. So those nodes will be the worker node or worker machine, where your containerized application will run. And keep in mind, every cluster needs to have at least one worker node. And then you will have the pods running under the node, which is like the uh, workload, where so your application workload, the pods are the components of your application workload. And then you see the control plane in the left side. The control plane basically manages the worker node and pods in the cluster. So it basically controls your worker node and your pod running on the Kubernetes cluster. It also takes care of high availability and fault tolerance. So this is a normal architecture of Kubernetes component. You see then the node has kubelet and kube proxy, and the control plane has other component like etcd, then API, scheduler. So let's discuss one by one. So what is control? So Kube API server is basically a component of a control plane. It exposes the Kubernetes API. The API server is like acts as a front end of the Kubernetes control plane. All the communication goes through the API server. And then you have HCD. HCD basically is nothing but is the highly available key value store database. It's not a database, but you can consider like a storing all your cluster data. So if your cluster crashes, then it helps the cluster to resume the state. So everything will be saved in etcd. Then we have kube scheduler of the control plane, which watches your newly created pod and see which are the nodes doesn't have that pod assigned and assign this pod to the node. So it's basically select the node for them to run on. So it's like takes care of the scheduling part. Have kube control manager. Kube control manager is basically is the control plane component that runs the controller process. Uh, Basically, each controller has their own separate process, but to reduce complexity, these are all combined in a single binary or and to run in a single process. So you can consider like a package together and running a single process. And then we have cloud control manager. Basically, lets you link your cluster into your cloud provider API. And then the other side, you have node components. Node components basically kubelet. Is the agent runs on each node in the cluster to make sure the containers are running on the pod. Then we have kube proxy, which takes care of the network proxy that runs on each node in your cluster, and that is implementing part of your Kubernetes service concept. And then we also have a container runtime, which basically a software that is responsible to running the containers. Let's see what is Terraform. Terraform is an open source infrastructure as code software tool created by the HashiCorp, and it user defines and provide data center infrastructure as a declarative configuration language, and then Terraform takes care of managing the infrastructure for you. So as you see in this diagram, the Terraform will have configuration file where you are maintaining or keeping your infrastructure configuration, and then it manages the entire infrastructure with a Terraform state file. So basically, you can think about it's a way to manage your infrastructure in the enterprise or companies. What we do, we need to provision thousand of EC2 instance, you have to provision 100 of EKS clusters. So doing that manually will take a lot of effort and it will be hard to keep up with the all management stuff. So that's why Terraform is a infrastructure as a code tool where you keep your infrastructure code in a configuration file, and it's a declarative approach. So you just declare the end state of your infrastructure, and Terraform takes care of everything else. So it takes care of the dependencies, it creates the environment for you. So that is done by keeping the Terraform state file. So Terraform actually keeps the existing or current or actual state of your environment or infrastructure in a Terraform state file. Terraform supports different cloud providers. These are few common use cases when you can use Terraform. When you want to maintain your infrastructure as code, like infrastructure as code to automate the provisioning of your infrastructure, including your servers, database, firewall, policy, or any other resource in your environment, you can use the Terraform. It is also used in a multi-cloud deployment. You can use with this is one of the main important benefit. You can use with your Azure, AWS, Google Cloud all together, so you don't need to worry about maintaining or keeping a different tool for all these cloud providers if you have a multi or cloud agnostic environment. Then you can also manage the Kubernetes resources, like you can create Kubernetes resources, you can deploy, you can destroy, you can manage your network infrastructure, you can manage your virtual machine on prem, you can also integrate with the existing workflows, CI/CD if you have, and also you can enforce policy as code, like if you have some strict security policy you can create with this Terraform code, and you can maintain them as a policy, as a code. And then also it takes care of your secrets, so you can inject secrets in Terraform code, so you don't need to save the secrets in your code. You can create automatically, you can dynamically generate secrets and credential with Terraform configuration file. So it's time to do hands-on. So AWS EKS with Terraform. So today we are gonna provision EKS cluster with Terraform. This is the Terraform code to provision an EKS cluster. I downloaded it from Terraform GitHub. I'll mention the link in the description so that you can try it out. Before we run the Terraform code, there are a couple of things we need to keep in mind. So they're prerequisite before we run. So you need to have a Terraform version 1.3 or greater installed locally. You need to have AWS CLI installed. You need to have kubectl installed. Kubectl is basically a command line tool for the Kubernetes. You can interact with Kubernetes cluster, and you can deploy application. You can manage your cluster. So that kubectl needs to be installed. I mention the link in the description so that you can install, and let me know if you have any question. So once you have everything set up, you need to have an AWS account before you run the Terraform code to provision the EKS cluster. Before you start running Terraform command from CLI, once you install AWS CLI, you will be able to configure your access key ID and secret key. So basically what you do, once you have the AWS CLI configure, you write or type your command AWS configure, which will ask you to enter your AWS access key ID. So you enter some access key ID, whatever you have, and then it will ask you to enter your secret access key. You enter that, and then it will ask you to enter the default reason. You enter that, and then you can enter your default format or leave it blank. Once you're done, then your AWS access key and secret key will be set up, and you will be ready to run your Terraform command. To see which account is configured, you can also write or type the command, which is AWS HTS get caller identity. You can see the main Terraform file. So basically, this is the main file where the Terraform starts executing. So we can see we are mentioning the provider as AWS, and then the reason we are taking the reason from the variable. So you mention all the variable in a different separate file, which is a variable Terraform file. And if we go there, you see I have variable AWS reason. The value is US is 2, and that's where it's coming from. Then we have a data source AWS availability zones, which is an empty array. That is going to be used later. And then we have a local variable, which is cluster name. Cluster name basically, there one this is the constant string, and then we are generating a random string by this logic where we are generating a suffix and appending that suffix with the cluster name, so that every time when we run, a unique cluster name will get assigned. Then we are calling the module VPC, the VPC module. So basically the module is a container for multiple resources. You can consider it like that. So every Terraform configuration file or configuration will have at least one root module, and then you can create multiple modules. So basically the modules you can call once or multiple times. You can consider like a subroutine. If you have a programming background, or if you have done coding in past, then you know how a subroutine you can call from multiple code and multiple way we can call it. So it's the same way we have module, which is an abstract, and that module you can call in multiple Terraform code, and then you can override some value whatever you need. So the same way we are calling this module. The source is the Terraform module VPC AWS, and this is the version. Basically it's coming from this GitHub Terraform repo. So the code is from here, and then the version is 3.19.0. So basically this is the tag number. So if we go to the tag, so the latest tag is version 39.19.0. So this is where the module is coming from. So that's where we are taking the source code, for this VPC module, and similar way we are calling the other module EKS, which will be coming from this path, and the tag number will be 19.5.1. And then we are overriding values on the module VPC. So the name we are giving educational VPC, CIDR block we are overriding, then availability zone we are taking from the data source, private subnet, public subnet we are overriding, and then we are overriding these variables. So as you can see, we are overriding a couple of variables, and then we are calling a different module EKS, where we are mentioning the cluster name. Cluster name is basically the cluster name, which is a local variable coming from the above, where we have the cluster name, and then this is the cluster name. And then we have next one, we have the version for the cluster version will be 1.24, which is the latest version. And then the VPC ID we are taking from the VPC ID of the module, and subnets the VPC subnet. So when the cluster will get created, it will refer to this VPC, and the version will be 1.24. Then we are using the AMI image type is this one, and then there's node group. We are creating a node group, which is node group 1, which is the name, and the instance type we are mentioning T3 small. Let's change it to the T3 micro. I'm gonna change it to the micro. I already deleted one node group because since it's just a test, so I'm just creating one node group, and you can see the desired size is the minimum size is 1, and maximum size 3. Desired size will be 2. So the node will be running, there will be 2 nodes running all the time. So that's what we are doing here. Then we have a Terraform TF file where we are mentioning all the providers and all the packages that needs to be installed when we run Terraform init, and the required version of Terraform is 1.3. So this denotes the version you should be having the Terraform is 1.3 greater than or equals to Terraform 1.3. That's what this symbol means. If you have the version is less than 1.3, then you will not be able to run the Terraform, and you will get error, version mismatch error. Now we have the Terraform output file. So basically the output file will list out all the output value. So once you run the Terraform apply, once the Terraform creates all the resources in your infrastructure, then it will give you the output. So here we are getting 4 outputs: the cluster endpoint, the cluster security group ID, and the region, and the cluster name. So first we are going to run Terraform format. So the Terraform format basically checks the format of your code, and if it's any adjustment needed, it will adjust. Say for example, if I write in this way or this way, and then I am making some indentation issue, then what Terraform format does, it will check and automatically adjust with the correct format. So this is what it does. So it's always recommended to run the Terraform format, and it will also show you the output, which file the format took place. So that's where you know which file has been changed by running the Terraform format. Once you run the Terraform format, then we can run the Terraform init. So the Terraform init is basically it checks all the initialization, and it will download all the package and all the providers, and then it will initialize everything. So let's see when we run the Terraform. So basically you are seeing it's downloading the modules from Terraform registry, and this is the module we are calling. So it's downloading the module, VPC module, EKS module, and then it is also downloading the plugins, which we have mentioned in this file, which is here. So it is downloading all the plugins. If you already downloaded, then it will just uh, skip it. Otherwise, it will download all the plugins and the modules. Once it's done, then you will get a message Terraform has been. As soon as it runs successfully, you will be able to see there is a folder created .terraform, which will have all the modules that has been downloaded, and also it will have all the providers that has been downloaded. So that's what the Terraform init does. Once it is done, then you can run Terraform validate. So Terraform validate is basically it validates for the syntax. It validates all the syntax of your code. If there is no syntax error, then you will get the message successful. The validation is success. Configuration is valid. So once everything is done, then now you are ready to run the Terraform plan. So basically, the Terraform plan what it does, it checks your actual infrastructure and your desired infrastructure that is mentioned in your Terraform code, and it matches. So what am seeing here, the 49 resources has will be added as part of this Terraform code. So basically it's creating all the 49 resources. So you see the sign plus, that means the resource will be created. If there is sign of minus, that means that resource will be removed or destroyed. That's how the Terraform checks all the resources in the infrastructure. And then you are seeing all as part of the plan. We know now, once we run that, then we have 49 resources to add. And also it's getting is giving you the outputs, which is as part of the output file. So what you can do, you can run the Terraform plan and save the plan in a file, and then run the Terraform apply referring to that particular file. Or you can also run directly, since I'm just running locally, so there is no other user who is running Terraform plan and apply parallelly with me, so I can just run it. I don't need to save in the file. So I know these are the resources I'm going to create, so I'm just going to run Terraform apply. And once I run Terraform apply, so what it does, it's going to create the resources. Before it runs and implement all the resources, it will ask me to confirm, so I give yes. If you want to skip this, then you can also go through the direct command, which is like Terraform apply, and then you mention auto approve, which will not ask you for your confirmation. So once you hit enter, it will create the resources. So let it create. Terraform apply just got completed. It took almost 10 minutes. So you can see in the output, the apply complete, resource 49 added, 0 change, 0 destroyed. And we also see the output variables. So the cluster point, cluster name, cluster security group, reason, that are coming from this output file, since we mentioned these are the value you want to see in the output. So once that is done, so you know all the resources are completed. Now the next step, we need to verify whether our cluster is healthy, whether the nodes are running, whether the pods are running. So we need to verify those. So let's verify that. So what I'm gonna do, I'm gonna set up my or configure my kubeconfig file. This is the command. What I'm doing, I am calling AWS AKS reason. I'm taking the reason from the Terraform output reason variable, and then I'm also taking the name of the cluster from the output. So once I enter, then it will be able to configure my kubeconfig. I'm gonna run the kubectl command. So first command is to get nodes. So let's see what is the output. So I can see there are two nodes running. So remember, we mentioned in the main output file, Terraform file, we mentioned there we need node group, and then we mentioned two desired states size. So there's two desired size, that means that two nodes will be running all the time. So as you can see, there are two nodes running, status is ready, that means they are healthy. And then we can also check the pod, which is there is no pod in the default namespace. So let's see it in all namespace. So we see there are all pods running, which is the kube system pods. They're also running and healthy. And then also we can check how many namespace we have. So we have this many namespace got created. So now we can see, verify this cluster is healthy and running, and all the resources are created. So next part, once you are done checking and verification, now you can destroy or you can terminate all the resources. To clean up the resources, you need to run the Terraform destroy. I hope this will help you understand about Kubernetes and Terraform, how you can work, create your Kubernetes cluster, support us to grow. Thank you for watching my video. I hope to see you in my next video. Thank you.